Hello and welcome. I'm Jackie Lynch and I'd like to thank you for taking the time to listen to this presentation. On the front page here you can see I have the link to the handout as well as some links to some articles that I have written about NIM that you may find useful. In this presentation we're going to go through a general introduction, then we'll talk about setting up NIM, working with makesysbs, using the NIMADM and a number of other commands. We'll also talk about the relationship between the VIO server and NIM, and we'll go over some hints and tips that I hope that you're going to find useful. You can use NIM to do some really cool things beyond just installing and maintaining systems. You can use it to back up and restore your AIX LPARs and VIO servers, and obviously you can update those LPARs and VIO servers. You can use it to install iFixes, and you can use alternate disk copy, install and clone to take copies or do installations on alternate disks so that you don't touch the current running system. NIM can also be used for migrations and upgrades, and you can also have an alternate NIM master so that if something happens to your current NIM master, you still have a functioning one. At the time I recorded this, the latest AIX was AIX 7.3.2.2 and AIX 7.2.5.8. Come December 12th this year, IBM's announced that they will be delivering the latest technology level, which will be AIX 733. And in that, there's been some changes to NIM. So NIMADM has been enhanced to support concurrent migration of multiple LPARs. Right now, you can only do one, and it's very frustrating. So being able to do multiple is going to make it much more efficient for us to be able to do these upgrades. NIM is also enhanced to better manage resources for multiple tenants or groups of systems, which hopefully will mean that we won't have to have as many NIM server instances. And there's been updates to the AIX collection for Ansible NIM enhancements. So the link on this slide is basically to that announcement, which also has a number of other things about the updates that are coming in December. So here's a couple of tips on setting up your NIM servers. The first thing is that your NIM server has to be at the highest level of AIX that you plan to support. So as an example, the VIO server 4.1.0.21 requires that your NIM server be at AIX 7.3.2.2 or higher. What I do is whenever IBM brings out an update to AIX, I always put that on my NIM server and then I build a whole new set of resources for that. When you're architecting your NIM server, you should use dedicated resources, even if it's an LPAR running on a system that has other LPARs on it. It should have its own SAN card and it should have its own network card. This is because you want to be able to use that NIM LPAR to restore your VIO servers, and you can't restore something that you're dependent on. By the way, this also applies if you have a TSM or other backup server. It should not depend on a VIO server that it needs to be able to restore. I also recommend that you don't combine NIM and something like TSM on the same LPAR because it makes for some very difficult upgrades. In terms of memory, I typically give my NIM server more like 8 or 16 gig. It will run with 4 gig, but as you go up to higher operating system levels, you do need more memory. You should have a separate volume group that holds all your NIM resources. They should never go into root VG because they're going to be large. And that is typically made as a scalable volume group because some of the files are also quite large. I normally create a file system called /nim in my NIM volume group. And I may also create one called /backups or /user local backups. That's the file system that I will NFS export to all my systems for doing makesysbs to. Then you need to install some file sets and any updates specifically for NIM. So that's the BOSS sysmanagement NIM master, spot, and client. And of course you have to have BOSSnet TCP server and BOSSnet NFS server installed on the NIM LPAR as well. And you could check those using the lslpp command. A couple of other things to note is that NIM does not like using the dot or period in a resource name, so you should always use the underscore. In order to finish up setting up NIM, You're either going to put the AIX DVD into the DVD drive, or you're going to replace what I have for /dev/cd0 with the directory where you put any of the BFFs in. And now you're going to run NIM master setup. And what NIM master setup is going to do is it's going to take all of the BFFs, etc., from the CD or from the directory that you give it. It's going to use /nim as the file system in volume group nimvg, and what it will do is it will create a /tftp boot file system, and it will create the basic spot and LPP source resources in /nim that you will use later. And the actual directory structure is listed on this slide, so you can see there's an /nim LPP source, images, spot, etc. It will not take a makes this be of the NIM server because the -B tells it not to. This slide I'm showing you what NIM looks like on my AIX73 system. So when I run an OS level -S, you can see that I'm at 7.3.2.2, that I have BOSS Sysmanagement NIM installed. I have about a 450 gig /nim. You may need a much larger /nim depending on how many makes this be images, how many LPPs and spots, etc. that you want to keep around. And then I did an ls-al on /nim to show you the different directories that I have on there right now. In order to use NIM, any of the machines that you want to be able to control have to have a resolvable name. Whether you have their IP and name in /etc/hosts, or whether you use DNS, you have to be able to do an NS lookup or a ping and find them by name. So in this case, my /etc hosts has the names and IP addresses of the VIO servers that I'm going to use, as well as the LPARs, and of course my NIM server. Also, when you look in inetd.conf, boot PS and TFTP need to be uncommented. Now, quite often your security team will do scans, and those are two things that they will flag. So I normally keep those commented out, and then when I want to use NIM to do something, I will uncomment them and refresh inetd. If you use any software such as TCP wrappers, you can't TCP wrap boot PS and TFTP. They simply won't work with NIM if you do that. You also want to check Etsy services and make sure that boot PS, boot PC, and TFTP are all in there. Those are required services. And you also need to make sure that if you have firewalls and routers between the systems you want to control and your NIM LPAR, that those allow boot P and TFTP to pass through. Once you've done the basic build of the NIM server, you're now going to want to create resources so that you can actually do something with it. Although when you did the install it created a basic LPP and spot, I normally create customized ones for each operating system level that I may want to be able to maintain. So I'll go to IBM's ESS website and I will download the DVDs as ISO images, and then I'll use SMIDI BFF create after I load them to create a source directory containing those images. And then I'll also download the latest service pack, because sometimes when you download the flash image, it's not at the absolutely latest service pack. So step one is I create an LPP source, and I do that using the command line, although you can do it using SMIDI. And in this case, I'm defining an LPP source, and I'm telling it that the images are in user local software AIX72TL5SP8-base. I'm telling it to grab all the packages, and then I'm giving it the LPP source location as well as the LPP source name. And I will typically put LPP underscore in front of an LPP and spot underscore in front of a spot. You can then update that LPP with any missing resources. So for instance, I have a directory called add-ons where I'll put some of the third-party add-ons that I have. I normally have a NetApp directory. If I'm using NetApp storage, I will load the NetApp drivers, etc. I also normally patch SSH, SSL, and Java. Those are almost never up to date in the base images that are put out because they change so often. And then I'll also use the nim-o show res to check for certain file systems. for certain packages. So here I'm checking to make sure that boss.net is in the LPP, and that also boss.alt.disk is in the LPP, because if I want to use alternate disk install, I have to have boss.alt.disk install boot images and boss.alt.disk install.rte installed. And then I always finish off with the nim-o check to make sure there's no issues with that LPP. Once the LPP is there, I then create the spot. Now this is specific to AIX LPARs. With VIO servers, there is no LPP, and we will get to those later. So here I define the spot, and now I'm telling it that the source instead of a directory is the LPP that I built. I'm telling it the location, which is, nim spot and then the spot name, and I'm giving it the actual name of the spot at the end. I then run a check, and then I may decide that I need to add something like boss.alt.disk install boot images, because sometimes that doesn't come across from the LPP. So I'll use the nim-o cus to do that. And I can use the nim-o show res on the spot, just like I did above with the LPP, to make sure that those really are installed. Once you've built the resources, you can run the ls-nim and pipe it to a grep-i resource. It will list all the resources. So here you can see I have a number of different resources in order to be able to support different levels of AIX and VIO servers. You can also break it out by telling it, just give me the list of machines. That way you can make sure that the LPARs that you want to work on are actually supported and listed as machines that you're going to work on. You can list groups, you can list makes SPs. So here you can see the makes SPs that I have for the different golden images that I keep around. On this slide I'm just showing you how to check resources for different levels. So I was checking the LPP for boss.suma, for the boss.alt, and I was also checking the Java levels that it was going to install. And then at the bottom I'm checking the spot to make sure that I have the boss.alt.disk install images that I need in there as well. On this slide I'm just showing you the output of ls-l when I look at my LPP source spot images and makes SP directories. The makes SP directory is one I typically add that I use when I am converting makes SPs from one version to another, which we will talk about later. This slide's just showing you the output where I look at the actual NIM volume group and how I've got it set up. And as I said, it is a scalable volume group, and I typically give it either a 512 meg or a 1 gig PP size, because there's going to be a lot of large files in it, and it's typically a large size. And at the bottom is just a list of the logical volumes that I actually have in my NIM volume group. Sometimes you'll also see /backups in there for when I put my backups directory in there as well. If you do an ls-nim-l on a machine, it's going to give you some interesting information. And one of the things that you want to look at is the CPU ID, and make sure that the CPU ID in NIM matches the CPU ID when you run a uname-a on the LPAR itself. It also provides information with respect to how you're going to connect, which is normally nim-sh, and it gives you the state, which in this case is ready for a NIM operation, which is what you want. When you do the ls-nim-l on the LPP source, it simply gives you information such as the fact that it is an LPP and the physical location where it will find that LPP. Another important line in that is the S-images line. That needs to say yes, otherwise you're unable to create a bootable image from this LPP. And later I'll show you how to correct that if it says no. And then when you look at the spot, it actually gives you a lot more information. It gives you the location of the spot, but it also gives you the output of the equivalent of an OS level -S, so that you can see what level that spot is actually set up as. And on this slide, we're actually looking at the VIO resources. So I searched on everything that had VIO in its name, and this is a list of one of my older NIM servers and what it had. So you can see I have a lot of makes SPs, boss status, and spots. But as I mentioned, there is no LPP. And then over on the right is an actually drilled down spot ls-nim, And again, it gives me the output of an OS level minus S, so that I can see what AIX level I would be going to. And when I look at that, I know that that's the minimum level that the NIM server has to be at in order to be able to deal with this particular spot in VIO. This is an example of some of the steps to install or update a 73TL2 SP2 resource. So first of all, my NIM server has to be at AIX 7322, which it is. So we're going to put the update CD in or change it to the directory where the ISO image was used to create and store files. So we would use load op to load the ISO image and SMIDI BFF create to create the install files in the directory. In order to update the spot and LPP source, you'd go into SMIDI NIM, perform NIM administration tasks, manage resources, etc. After you select the spot, you're going to select update all and point it to the update CD or directory. And the same with the LPP. Or you can create a new LPP in spot, which is typically what I do when I'm adding resources for different levels. So that would be the example I've got below, which has the actual command line commands where we do the nim-o define. I point it at the software AIX73, the base, which is where I did my SMIDI BFF create to, and I go and create the LPP. And then I update the packages with any updates that I may have. And I use the nim-o define to build my spot from that LPP. And I check my spot in my LPP. The command at the very bottom, the nim-o reset, is there because sometimes you'll allocate things to an LPAR and you'll start it doing a restore and then you realize that you actually don't want to do that. And so the nim-o reset will actually change its status so that you can do another NIM action against it later. So typically there are a number of iFixes and eFixes that get installed on a system using eManager or similar. Those can be installed manually after a NIM install, or they can be added to the spot so they go on automatically. So after you build your LPP in spot, you put your eFixes into a directory. Using the example of for 7256, I wanted to install IJ46487. I went into my NIM file system, into the LPP source for the specific LP. I added an eManager/PPC directory, and then I copied the specific eFix from where I store them into that eManager PPC directory. And then when I ran my nim-o cust against the LPP source, I told it what the file set name was, but notice I didn't give it a directory because it knows that it's going to use the directory for that specific eManager PPC. You can also list the eFixes that are installed in a spot using the nim-o lslpp, and you can uninstall a fix by using the nim-fo maint and the flag of -u. So this is how you install and uninstall iFixes into a spot. Now let's look at what you have to do to set up a client to restore from a make-sysb. The first thing is to make sure that the name for the client can be resolved from the NIM server, whether it's an Etsy hosts or DNS. Try a ping or an NS lookup, or just do a grep on Etsy hosts, but make sure that that client is in there with the correct IP. Then you create the client machine to NIM as a machine object. So you'll go into SMIDI NIM, perform administrative tasks, manage machines, define a machine. You'll put the host name in exactly how it is in Etsy hosts or DNS. You'll select your network type. It's always going to be a 64-bit kernel nowadays, and the shell should always be NIMSH. And then 99% of the time the network interface is going to be n/a. Once it's completed, you could do an ls-nim and you can grep AIX2, which is the name of the LPAR I was putting in. You can also do an ls-nim-l on AIX2 to get more information. And then you may or may not want to create an image data specifically for that LPAR. One of the main reasons for creating an image data file is so that if you happen to be mirrored and you take a make-sysb, when you do the restore, you may not have two disks to restore it to, and you can deal with that in the image data file. And the way you do that is you create an image data file. There's a template that I gave you the link to, and you basically can specify things like, don't shrink my file systems, I don't have to have an exact fit, set copies equals 1 so that I don't have to deal with the mirroring, and so on. If you don't create an image data resource or specify one, NIM's going to use the one that is embedded in the MakesSB image itself. So just be aware that you do have the ability to restore a mirrored system without having to mirror it again. And then the next step is you're going to use the MakesSB resource for a restore, so you need to go and set that up. I typically have all my MakesSBs in a separate file system called /backups because I have it NFS exported to all my systems so that they can just automatically do MakesSBs out of their cron tab. When I want to use a MakesSB, I will copy it into /nim/images, and then I will create a resource for that. In this case, I'm using my golden image. It's already in /nim images. So I'm just going to go through and define a MakesSB resource, give it a name, and then give it the actual location. And you could do that with SVID, or you can use the nim-o define command, which is what I have just below. When you're doing it for a VIO server, you're going to be using the MakesSB image that you took out of the Flash ISO that you downloaded from ESS. You do not use any other MakesSB image unless you actually have taken a specific MakesSB of that VIO server. You can't use a generic AIX MakesSB with a VIO. If you do use the ls-nim-l, you can get a list of the MakesSB images, and you can also see what the location is for the MakesSB. So you can see that for my MakesSB for AIX7258, it's in /nim images AIX7258.MakesSB, and you can also see where I've got the VIO server 41021 MakesSB image as well. And it's got Flash in it because that means that I took that image straight out of the Flash ISO. So there's two steps to checking your MakesSB for a VIO server, or actually any LPAR. The first thing is I run an ls-nim-l against the name of the MakesSB and find out when it was created, is it ready for use, what's the actual physical location, what OS level -S. So this is a 7322, so that tells me my NIM server must be at 7322. And then I will take the location and I will do an ls-l on it just to make sure that I actually did remember to copy the MakesSB image into that location. Once I have my MakesSBs in place, then I decide to use them to restore something. In this case, I am telling NIM to use an AIX7258 MakesSB, and I plan to use it to install on my AIX2 machine. So you can do it using SMIDI-BOSS-INST, or you can use it doing the NIM commands. I typically allocate the spot LPP and MakesSB ahead of doing the BOSS-INST. That's what the command line ones are showing you down below, where I do a nim-o allocate on the LPP source, the spot, and the MakesSB. And I also did a BOSS-INST data, and I had an install P bundle of my NetApp drivers. But you can do different flavors of this, but I do my allocate ahead of time typically. Once I have my resources allocated, then I'll do my nim-o BOSS-INST. I'm telling it the source is the MakesSB to accept the licenses. Do not boot the client, and why I do that is because I want to have everything set up, and then I'll boot the client into SMS mode myself, and I will monitor the actual installation as it goes. So this is setting it up for what I call a pull install. If I had boot client equals yes, it would be a push install, and it would try to immediately reboot the client to do the installation. This is showing you what the SMIDI NIM BOSS-INST screen would look like when you're doing install of the operating system. So you've got my system name, which is AIX2, the fact that I'm doing a MakesSB install, and then it shows you that I've allocated a spot LPP and MakesSB. I normally set accept new license agreements to yes, so that would need to be changed. and then you go down to initiate reboot and installation now, and I normally set that to no, so you would change that as well. If you leave it at yes, it will reboot immediately to try to do the installation. And this is just showing you the output of the ls nim-l AIX2, which is showing me that it is ready for a NIM operation, and that I did a reset to make sure that everything was clear before I started doing anything else. Prior to booting the client LPAR into SMS mode to do the install, I do some additional checks on the NIM server. The first thing I'll do is a show mount -E and make sure that the makesysb and LPP and spot are all NFS exported to the client LPAR, and they are. I'll also look at the end of etc boot ptab and make sure that my LPAR is listed in there with the correct IP, correct subnet masks and gateways, etc. And then I'll check TFTP boot, and I will look to make sure that the client and the various IPL records, etc. are actually in there. In this case, I actually just did a grep on VIOS because I wanted to make sure that my spot was in there, but you would typically do a grep on AIX2. Earlier I had mentioned that when you do the ls-l on an LPP source, you want to look at the S-images line to make sure that S-images is set to yes. If it is set to no, you can actually recover that by doing this nim-o update recover equals yes against the LPP, and you need to point it at the base that you built that LPP from so that it can grab the information it needs from there. When you're doing allocations, you can deallocate and allocate things to and from the spot. And of course, I've got here the command for doing your boss inst. There's some other things you can do. You can add file sets if you want to an LPP source, and you do that using the nim-o update. And under packages equal, instead of all like we normally use, you would put the actual names of the packages. And you can also use the rm images to actually delete images out of an LPP source if you don't want them in there. I also recommend that you become very familiar with alt-root-vg op, because that is the command that is used for most of the alternate disk installation things that we're going to talk about. Now, if you've done your SMTBoss inst, but you've decided that you're not going to actually do that upgrade now, you're going to have to do what we call a backout. So even though you haven't booted in SMS mode, NIM still has everything for that system set up, ready to go. And the way you get around that is with the nim-o reset. And then you can also use the nim-fo deallocate to deallocate the resources. I've had to do that a couple of times where I accidentally allocated the wrong thing and got it all set up and then went, oh yeah, that's not going to work. After you do an LPM move or you do some kind of server migration so that the LPAR is now running on a different system, you may need to update the CPU ID. So if you run uname-a on the client, it's going to give you a CPU ID, and it'll look something like the 00CE, etc. that I have in there. Then on the NIM server, if you run like a nim-o lslpp or some other command to that client LPAR and it fails, what you want to look at is the varnim ras nimshell.log. And if you see a line something like error local value passed does not match environment value, that means that the CPU ID on NIM is incorrect. And so you would use the nim-o change and put in there the actual CPU ID that you got from the uname-a. Another thing you should check as well is that the NIM client is actually running on the client. So if you do an lssrc-gnim client, if it's not running and you're about to try to do a NIM action, then you should actually start it. And that's what the start source command at the bottom is about. One of the things that you can run into with VIO servers and actually with some LPARs is if you are using aggregation. NIM does not like aggregated networks. If the client's using aggregation, the network install will fail. There are ways to get around it, but they're a little convoluted. And this is one of the reasons why a lot of people have a separate admin network on a single port that they use for installs. Otherwise, what you typically will have to do is have the network people unaggregate so that you have an access port. Then you do your installer recovery and then they re-aggregate. Again, just something to be aware of and something that you should test to make sure that you know how to get around it if you have to. If you're installing onto SanDisks, the SAN team, before they do their zoning and mapping, may need you to light up the adapters. So there's multiple ways that you can do it. The easiest way is to go onto the HMC and go into the profile and then select virtual adapters, check them all, and then go Actions Advanced, Log in, Log out Fiber. You can then tell it to log in the fiber and it should light them up so that they can do their zoning and their mapping. I also have a link here for you on troubleshooting NIM LED hangs, because sometimes you'll be trying to do an install and NIM appears to hang, so that's well worth keeping it in your back directory. Several years ago, IBM started recommending that people use AIX PCM rather than STD PCM, and STD PCM is no longer supported. So the links that I have here for you are really just telling you how to use AIX PCM and some articles on MPIO resiliency and problem determination that I hope you find useful. Okay, so we've checked everything and now we're ready to do the install or the restore. So the first thing is we boot the client into SMS mode from the HMC. You could do it from the server, but it's a lot harder, so just do it from the HMC. And we select option 2 for set up remote OPL. And then we're going to go through, and now in this case I'm selecting the first Ethernet, but you need to check that you have the correct Ethernet port for the access port that you're going to install over. We're going to pick IPv4 and boot P, and then we're going to set up all of our IP parameters. So we'll select 1 for IP parameters, and then we'll select 1 for the client, 2 for the server, etc., etc. If the client and server are on the same subnet, then I don't typically fill in the gateway. Otherwise, if they're on different subnets, you're going to have to put the gateway in. And then you hit escape to go back one, and you go back and select adapter config. I always make sure spanning tree is disabled so that it doesn't slow things down. And the protocol is set to standard. Now this is the one where if you are aggregated, there's a couple of other options that may or may not work. So I am typically using standard. And then I basically use escape to get back to where I can do a ping test. And option 1 executes the ping test. If the ping test is successful, then you have a reasonable chance that your install will work. Not a guarantee. If it's not successful, it absolutely will not work. And then you go and select boot options. You select your boot device, which is the network, boot P, etc. And then you check normal mode boot and yes to exit. And at that point, it's going to go off and start doing the things that it needs to do for the installation. So the LPAR's going to boot, and you should see TFTP start up as well as boot P. It does around 30,000 to 50,000 packets, and you should get a console prompt. The other thing is, it quite often will go through that TFTP process twice, so don't freak out if it does. So then you're going to hit F1 and enter when it prompts you for the console. You're going to choose, in my case, 1 for English during the install. Sometimes you'll get an error message that says all logical volumes have been created exactly as they were, but the disks are not the same. Unless there's a strong reason not to, just go ahead. And then choose 1 to continue the install. Now I always then select option 2 to check the install and settings for a number of reasons. The first one is I want to make sure that only 1 disk is chosen and that it is the correct one for root VG. Now if you're running something like a NetApp, it's going to pick a disk for every path for the NetApp, and you're going to have to go and unselect them so that it's only picking 1 disk. And this can be an adventure, but that's a whole nother session. So in this case, I'm choosing HDisk 0. I don't bother with maps for installation, and I make sure that import VGs defaults to no because I don't want it to import any volume groups, and then I use 0. Now the installation should start. And from your NIM server, you can monitor it using the ls nim -l LPAR name, or the easier way is to be on the HMC monitoring the reference codes. Whenever I'm doing one of these, I'm SSSH to the HMC. I use VT menu to get a console so I can literally watch it throughout the whole boot. Then once the system reboots completely and it's done, you can import any volume groups, remirror root VG if that's what you want to do. I only ever mirror it if it's on local disks, and perform any further tailoring. It might be putting on e-fixes, it might be adding additional apps, depends on what you need to do. On this slide, I've just listed a bunch of useful commands that I think everybody should have in their back pocket. So make sure that you know how to use these commands, or at least have the man pages downloaded to a PDF somewhere, just in case you need them. If you run ls-nim-o against a resource such as the MakeSysB, it's going to give you the list of actions you can take against that object. So in this case, I can remove it, define it, change its attributes, or show its contents. If I use the ls-nim-l, it gives me the information specifically about that MakeSysB, such as the OS level, the location, and so on. In order to communicate, there is a file called /etc/nim-info on both the master and the client. This is what the one on the master will look like, and it's only going to have 5 or 6 lines, which is basically, I'm the master, this is the master configuration, here's my ports, and my host name is AIX1NIM. Now those master ports are interesting because occasionally for firewall reasons you may need to change that port number, in which case you would change it here, but you would also need to change it on all of the clients. You will hear people refer to the NIM master database and files. It's not really a database, it's just a bunch of files. And they live in /etc obj-repos, and they all start with NIM. And then the logs are going to be in /var adm ras nim. So you can also look at the actual NIM log by using the alog command, and that will show you any failed NIM operations. So as you can see, there's really a couple of different logs that you need to be aware of. In order to back up and restore your NIM database, really what you have to do is save the following NIM files. So there's a /etc/nim-info, and then an etc obj-repos. It's all those files that start with NIM. And you can restore the NIM database and activate the NIM master using SMIT or the command line. And you could also restore these files that you use to back up the NIM database. If something happens to your etc nim-info and you don't have a backup, you can actually rebuild it on the master using the NIM command, the NIM config command. And from a client, you can rebuild it by telling it to run nim-init and give it the NIM master server LPAR name and the client and its own name, and then point it at port 1058. You also want to make sure that NIM is actually starting on the master, and that should be an etc init tab, and it'll be the nim:2:wait command line. And you can see it does a start source -gnim. So you could do a ps-ef grep nim and see if it's actually running if you wanted to. This is what /etc/nim-info typically looks like on a client. So the NIM name is the LPAR name, then the host name, actually I have a fully qualified name. It's a standalone server. It's going to talk to the NIM server called nim201.local. You've got the ports that match up with the ports that are specified in the etc info on the master. You can see I've got my CPU ID. And there's a bunch of different lines in here that you should expect to see. And then it has a routes thing at the very bottom. So this is typical of what you would expect to see in a /etc/nim-info on a client. As I mentioned earlier, NIM can be used for migrations and updates. So a migration is where we change a version or a release. So AIX7.1 to AIX7.2, or AIX7.2 to 7.3, or heaven forbid AIX6.1 to 7.3. That would be a migration. An update is where the version and release don't change, but you might change a technology level or a service pack. So you might be going from 7.2.4 to 7.2.5 or 7.2.5.3 to 7.2.5.8. Those are updates. And both migrations and updates can be done to an alternate copy of root VG if you have an unused disk available. And what you would do is put all the changes on the alternate disk and then point to the new disk using boot list and boot it and test it. You should always migrate or update your NIM master first, as I've said several times. The NIM master has to be at the highest level. And then make sure you have an LPP source and spot that are set up for that version release TL and SP. If you're doing migrations, you can use NIMADM, and it can be done a couple of different ways. You could take a down level MakesSB and migrate it to a new MakesSB, or take that MakesSB and migrate it and install it, or install a new golden image. There's multiple flavors of this that you can do. And you can use NIMALT clone with an update all to update a TL or SP. And I'm going to touch on multi-boss a little bit later. Earlier I mentioned that I keep my /NIM as a completely separate file system, and I don't allow any other file systems to be in there. And specifically, I'm thinking of things like my backups file system. I always create a separate file system called /backups or /user backups, and I take my MakesSBs to that. This is because of the way that NIM exports MakesSB images. So when I set up a MakesSB install, it's going to export /NIM/images/ whatever the MakesSB name is as a file to the client. But if someone tries to take a MakesSB to that same directory, then it's going to export the whole directory, and you can't have a file within a directory NFS exported at the same time that the whole directory is. So that's why you keep them separate. Now there is a way around that if you really want to do it, where you can export the nim_makesSB_subders environment variable. Personally, I just want to keep my backup separately because I also back that up to a backup server so that I can always get my MakesSBs back. NIMADM is an incredibly useful part of NIM that allows you to do updates to a separate copy of the disk. So examples of what you can do are creating a copy of root VG to a free disk, and at the same time that you're doing the copy, migrate it to a new version or release. This leaves the original copy untouched that you're running on and allows you to create a completely updated new disk. I can also create a NIM MakesSB resource from a copy of root VG, and then later on use that MakesSB to restore to a new version or release of AIX. And there's many other things that you can do with NIMADM. You can use the man command, man NIMADM, and you'll get some man pages on what you can do with NIMADM. In order to use NIMADM, you need to make sure that boss-alt-disk install.rte is installed into your spot. Otherwise, you'll get error messages. Additionally, make sure that Etsy and NitTab and etsy-inetd.conf do not have any errors in them. I had a situation where it went over a line, and that actually screwed up all of my MakesSBs that I tried to create. In the command on this page, what I'm doing is I am taking a current MakesSB, which is CG-AIX61, and I am creating a new MakesSB called CG-AIX71. To that MakesSB, I'm applying the spot and LPP for AIX71. So basically, I'm migrating a 6.1 LPAR to 7.1, but I'm doing it by creating a MakesSB that I can then use to restore. An alternative thing that you can do is add -D space HDisk something, and it will actually do the conversion and write it out to the other HDisk. So on this slide, I'm just showing you the couple of things that I just talked about. So we check what we have for root VG, and you can see there's a disk there called alt-inst root VG, which we have to export to use it. So in this first case, I'm basically taking a copy of root VG, creating a NIM MakesSB resource that's been migrated to the new version, and then I can use it to restore later on. In the second case, what I'm doing is I'm taking a clone of the root VG and writing it to HDisk1, which is the one that we just exported alternates root VG from, and I'm applying the LPP in spot for the new level, and so it will take the current level, write it out, and upgrade it on the fly. And then you reboot from the new disk, and you should be running at the new operating system level. I make extensive use of alt disk copy. Anytime that I'm doing an upgrade, if I'm doing it live, I will always take an alt disk copy to a second disk so that my recovery is simply to set the boot list to the other disk and then reboot it, and I'm back where I started. If you look at the command that I've got here, the alt disk copy -v -b -d, the -V puts it in verbose mode. The -B says do not change the boot list. Otherwise, by default, it will change the boot list to the disk that you copy to. And then the -D is specifying the specific H disk that you want to use. When you upgrade VIO servers to version 3 or to version 4 from an older version, under the covers, IBM uses an alt disk copy. They use that to create the new disk at the old version, and then they upgrade the new disk to the new version. So alt disk copy is used a great deal. So the other thing that you can do is use SMIDI alt nim alt clone and tell it the target client and the target disks, and you can point it at a fixed directory, and it will basically take the clone on the client. It will then do the updates on the client, and you then have the option to set the boot list and reboot to the new disk. Or if you have a problem, you can reboot from the old root VG. So you have a nice fallback, which is something that's very important to include when you do updates. With that said, when I'm doing any major updates, I still do a make SysB as well, before and after. So in order to take advantage of this, you're really using something called alternate disk install. And in order to have an alternate disk install or to take advantage of alt clone, you have to have a spare hard disk or LUN that's the same size as your root VG. So whenever I request disks for a new LPAR, I always request 2 for root VG. And it's not because I'm going to mirror it, because it's on the SAN, so I don't typically mirror. It's because I want that second disk to be able to use for cloning. You have to make sure that boss.alt.disk install RTE is installed and up to date. And then you can do things like create bundles to install to the new disk, or you can take a make SysB of the system to a file. You can clone the root VG using SMIDI alt clone or alt disk copy. And once you do that, if you do an LSPV, you'll now see one disk as root VG and the other one as alt inst _ root VG. If you've booted from the new disk, the original root VG will show as old _ root VG. If you use the alt disk install process, it will change the boot list, so you should always check after any of these processes whether or not the boot list is what it was before you started, and change it back if you're not planning on rebooting to the new operating system immediately. And as I mentioned, you can actually use alt disk install to do the upgrades to the new hard drive, and then boot that when you're ready to boot it. And if you're having problems with NIMADM, you can actually create the migrated make SysB and then copy it to the client and restore it on a separate disk. So you do have a lot of options and a lot of freedom when you're using NIMADM, alt disk install, SMIDI alt disk clone. So this is an example of what the GUI looks like when you go in to do an alternate disk installation. And since AIX53, the alt disk install command has actually been replaced by a combination of alt disk copy, alt disk make SysB, and alt root VG op, but it still works. So you can see I've got the commands listed. Over on the right is what the GUI looks like, so you can see it's installing a make SysB on an alternate disk as one of the options, or just cloning the root VG. So that would be your alt disk copy. And when I do my LSPVs, you can see that I have my root VG in my spare disk, and I always check to make sure that the boss.alt images are all installed as well. If I select install make SysB on an alternate disk, this is the next thing that it brings up. So basically what I'm doing is I'm telling it that I want to install it to HDisk1, and then for the device or image name, I point that at the makesysb image that I want to install to that HDisk. I can also give it an image data file if I have a customized image data file, and if you recall from earlier, that's something that we will sometimes do if we have a makesysb that was mirrored, but we're restoring it to an unmirrored system. And then down below you'll see that I've got set boot list to boot from this disk on next reboot, and I set that to no. I also set reboot when complete to no, and I always go for verbose output. So that would be the -V that I had on the command, and the set boot list to boot from this disk would be the -B, which means no, don't do that. Then you'll see it starts running, and here you can see that it's actually creating the clone. This is where it's copying the root VG volume group over, and then you'll see lots and lots more commands as it restores from the makesysb image, and that's because we chose verbose mode, so it's actually telling us what it's doing all the way through. So when you're doing this alt disk install, it really does go through 3 phases. The first one's where it creates the volume group and all the logical volumes, and it restores the makesysb or root VG data. The second phase is where it's going to run any customization scripts, installs any updates, fixes, etc. that you've told it to install, and it copies a resolve.conf file if you specify it, and basically sets it up to remain a NIM client if you told it to do so. And then the final phase is where it unmounts all those alt-inst file systems, renames them, and renames the logical volumes, fixes the ODM, and varies off that volume group. And then the last step, if you allow it to do so, it will set the boot list, and it will reboot if you told it to reboot. While the alt disk install or clone is running, if you were to do an LSPV on the current root VG and on the new root VG, you would be able to see the different logical volumes that it's mounting. So basically for every file system on root VG, you should see a clone of it over on HDisk1. And you can see that we have HD4 on root VG, and over on HDisk1 we have alt_HD2, alt_HD4, which is /alt_inst. And like I said, when it's done, it varies the volume group offline after renaming all of these file systems. Now, after you do the alt disk install or the alt disk clone, sometimes you need to change a file because maybe you've renamed a host or something. So one of the things that you can do is you can actually wake up the other disk, and then you can edit a file over there, and then you can basically put it back to sleep. So what we do is we do the alt root VG op-W-DH disk 1. That wakes up the disk, and it will basically vary it on, rename all those file systems so they are alt-inst, etc. And then if you wanted to rename to edit the host file, you would edit /alt_inst/etc/hosts. And then when you're done, you simply put it back to sleep using the -S instead of the -W. So this is very useful if you're creating a clone but you need it to be on a different network or something like that. You can go in and you can change it on the new disk. And this slide is just showing you that if you were to run the df command while the alt disk is running, you would actually see not just //user/var, but you would see /alt_inst/alt_inst/user and /alt_inst/var and so on. So for every regular root VG file system, you'll see a /alt_inst version of it as well. And then when the clone is finished, those all get unmounted. So this is an example of doing an upgrade on the fly. So I'm telling it to take my current root VG, which I happen to know is at 7300, and I'm cloning it to HDisk1, and then I'm going into /updates, and I'm going to put on the fixes there that will bring my cloned root VG up to AIX 73.0.1. Because I've got the -B, it's also saying do not change the boot list. So it will, if I was to reboot, it would reboot from HDisk 0 instead of HDisk 1. And if I leave that off, it will automatically set the boot list to HDisk 1. Basically, this is allowing me to copy the running system and put maintenance on in one step. And then another option you have is just to do a quick alt disk copy without making any changes, and this is what I use for quick backups. If I'm putting on a few patches that don't need a reboot or anything, I will do an alt disk copy just to make sure that I always have a way to go back to how things were before I actually did anything. And this is an example of using NIMADM to take a makesysb of my 7.1 system and then create a new makesysb image at AIX7.2, which I can then use later on. So basically I'm doing a conversion. And the steps are obviously taking the makesysb. I then check the makesysb to make sure that rc/tcp/ip and inetd.conf are in there. And that's because I had a problem in an earlier upgrade where there was a bug where a line on inetd.conf went over 2 lines, and it caused the converted makesysb to drop over 2,000 file sets. So by doing this listvg backup of the makesysb after I take it and checking on those 2 files, if they're copied, at least I know I haven't run into that problem. It would be pretty unusual too, but it did happen. So then the NIMADM command is basically taking that makesysb that I took at AIX7.1 and using the LPP and spot for 7.2.1.1 to upgrade that to 7.2 and saving it as another makesysb image. And then I check the converted makesysb and make sure the answers match the listvg backup from before. If I'm happy, I can copy it to the client, and then on the client I can use the alt disk makesysb command to take that makesysb and write it to HDisk 11. And then when I'm happy, I can boot from the HDisk 11, and I'm basically rebooting my image that's at AIX7.2. And you can do it for 7.1 to 7.3, 7.2 to 7.3, and so on. This is one where you will have to make sure that at the end you check that the boot list is set to whichever volume group that you want to be booting from, either the original root.vg or this new migrated one. And here I'm just showing you what you should expect to see when you do that listvg backup and you're checking to make sure that rc.tcp/ip got copied. So when I do that, it's showing me that there are 3 versions of rc.tcp/ip. One is in user lppboss.net and strut etc. The other's in user shareman info. And then there's the one that we really care about, which is /etc/rc.tcp/ip. You can also use NIM to backup, install, and update a VIO server. Now, if you're doing an installation or anything with a VIO server, there are only 2 files. One is the spot resource, and the other one is the VIO server makesysb image. You never ever update a spot from an LPP source, and there is no LPP source associated with VIO servers. One of the best ways to destroy a VIO server is to apply an LPP source to it. So the first thing is you need to make sure that your NIM master is at the right level to support the VIO server image. In my case, whenever a new level comes out, the first thing I update is my my NIM master. So it is always at the highest level. That way I know that whatever else they bring out, I should be able to support it, whether it's AIX or my VIOs. When you're updating a VIO server from a NIM master, you're either going to use update iOS or VIOS upgrade. So when you're doing just regular updates, it will be the nim-o update iOS command. I had mentioned that you need to have your NIM master at the correct level to be able to support the VIO server. So I provided the link here, which is what we call the VIOS to NIM mapping link. Unfortunately, it hasn't been updated for a while, but you can see here it says that for VIO server 410 or 41010, your NIM server must be at least AIX7.3 2.1. Now, if you look at the VIO server 41021 release notes, which is the latest VIO server, it actually has a piece in there that tells you To go to this VIO server level, your NIM master must be equal to or higher than, and in this case it's AIX7322. So I would always check the release notes or README as well as this VIOS to NIM master to make sure that your NIM is at a high enough level in order for you to be able to install, update or restore your VIO servers from NIM. In order to work with VIO servers from NIM, there are some specific resources that you have to install. The first thing you have to do is get the makesysb image from the VIO install ISO image. So I download from ESS the Flash ISO. They provide you with two different sets of ISO images. One is a 2 DVD set, and it's usually actually not at the highest level. So for instance, it would be at 41020, or you can get a single makesysb image on the Flash ISO. So I always go with the Flash ISO because I don't have to concatenate makesysb images from multiple DVDs. That Flash ISO I download and I copy it into my images directory, which is /nim/images. I then create a makesysb resource from it and give it a name, and then I will define the spot that I need to use for NIM with the source of that makesysb image. So you'll notice that there's no LPP or anything associated, it's just the makesysb and the spot, and then I always run nim-o check against the spot and the makesysb just to make sure that there are no issues with them. This is showing you in a little bit more detail what the steps are, where I copy the makesysb image. And the way that I do that is I put the ISO on my server. I use the loop mount command to mount that ISO image so that I can copy the makesysbs off it. And notice that when I mount the makesysb image, the dash of capital V is UDFS. It is not CDRFS like it normally would be. It's in a very specific format. I copy the makesysb image into my images directory, and then I can build my makesysb resource, and I can define my spot and do my checks, etc. And I also copy the boss.inst.data from the DVD or ISO image and create a VIOS boss inst resource so that the VIO servers have their own. Then I go through a number of checks. So here I'm doing an ls-nim-l on the actual makesysb. This one happens to be for VIO server 3.1.2.21. And what's interesting about that, you'll see for the OS level, it does not show me that it's VIO server 3.1.2.21. Instead, it actually shows me the AIX level. So if you were to log on to the VIO server, do an OEM setup env, and then do OS level -s, you would see 720005022114. Here we're running the ls-nim against the actual spot, and it gives you the status that it's ready for use. It also gives me, again, the OS level -s, and it also does not tell me the actual VIO server level. That's why you'll see whenever I create a resource, I put the VIO server level in it. So makesysb_VIOS 31221 is telling me that this is a 3.1.2.21 VIO server. Man page on NIM for the update iOS command is very useful. So here I've given you the man page with some of the examples of what you can do, so that you can look at that and take advantage of it. So we use the NIM update iOS for doing updates. So that would be like a technology level, service pack, that kind of thing. When we're changing versions, so when we're going from version 3 of the VIO to version 4 or version 2 to version 3, we use the VIOS upgrade, and there are two different versions. There is one on the VIO server, and that's the first link that I have here, and then there is one for NIM, which is the second link that I have there. You could use it to form a boss inst upgrade, you can use it for an alternate disk upgrade. When you run it from the VIO server, it only does it to an alternate disk. From NIM you have a couple of other options. So we can do the VIOS upgrade -q-n, and what that will do is backs up the virtual logical configuration, does a new VIO server installation from the image, and then will restore the virtual and logical configuration. Whenever you do VIOS upgrade, it's going to reboot 2 to 3 times during that time, so don't be surprised when it does that. And that's because after it does the install, it then has to reapply the virtuals and logicals and then reboot to it to actually implement them. In order to go from VIO Server 226 to version 3, you need to get to at least 2.2.6.30, and that's because of changes in the VIOS upgrade command. For VIO Server 41021, as I mentioned, the NIM master has to be at least at 7322, but you can actually upgrade using that flash image for 41021 from VIO 310 and higher. So if you're at 226, you've got to get to version 3, and then you can go to version 4, which is the latest. This is an example from the man page on my NIM server when I did a man VIOS upgrade, and it's just showing you some of the different options that you have when you use the VIOS upgrade from NIM. What I do recommend is that you should pick one. Either you always do your upgrades from NIM using VIOS upgrade, or you always do them on the VIO server, because the syntax between the two is quite different, and it's very confusing if you try to hop between them. So there are a couple of different types of backups that you can do for your VIO servers. The first thing is you should always use the VIOSBR command to make sure that your user-defined virtual resources for your VIO server are backed up. If you don't back them up, and then you go to do a restore from a makesysb or from a NIM resources tar, you're not going to have your virtual resources, and you're going to have to do all your mappings all over again. So it's very important to back those up. So with the VIOSBR, you do a dash backup and you save them somewhere in root.vg, and then you can view them or you can restore them from those files. And by default, it will put them in /home/padmin/ I think it's CFG backup. Now, additionally, you want to take a makesysb type backup of your VIO server. So I mount my backups directory, and then I run the backup ios command. And if I just run the backup ios command, and I always put -no media lib because I don't want the media library backed up, it can make for very, very large makesysb images. So this will create a NIM resources tar package, and that can be used to clone or restore VIO servers using install iOS from your HMC. So you would then load that file to the HMC and restore from there. Or the other thing that I do, and I take both kinds of backups, is I add the -makesysb flag so that I actually take a regular makesysb to my NIM server, and that way I can use that to actually restore using the makesysb image. Being paranoid, I take both kinds of backups. So be aware that that's something that you should think about. What I'm finding more and more is that people are always about backing up the data, and even for AIX, so often they forget to do a makesysb. And for your VIO servers, you also need to add those into that makesysb pool. So I have a script that runs on my VIO servers in Chrome tab that basically mounts the backup directory. It actually unmounts the file-backed optical directory or the media library, because for a while there was a bug where even when you said no media lib, it still tried to back it up. And then I run my backup, which creates just a regular backup NIM resources tar file, and I run a second backup which creates a pure makesysb file, and then I remount the media library. I run it in Chrome tab, and I typically do it on the 1st and 15th of the month, but you could pick whenever you want to do it. Depends on what your backup requirements are. I also regularly grab an HMC scanner report, and sometimes I'll also grab a sysplan from the HMC so that I have as much documentation as possible in case something goes wrong. If I am taking advantage of having a media library, which we also call file-backed optical, I typically have a third disk in my VIO server, and I put it in its own volume group called FBOVG, and that's where I mount the media library as a file system. So this is showing you that when I do my backup iOS and say no media library, it still creates the information for the volume group for FBOVG, which is what I call it. It then does the backup, and then after a period of time it finishes. What's interesting is this will create the NIM resources tar file, which was about 21 gig here. But during the process, that file can get very large, and in fact I saw it get as big as 40 gig for this particular backup. So it's really important that whatever you're backing up to, you have plenty of spare space, even though you may not end up using it all, because during the actual backup, it will expand and shrink whatever its needs are. And then if you use SMIDI makes this be, which you can do, one of the things that you want to do is check the last 20 lines of the smit.log, which by default will be in /home/padmin on the VIO servers. On a regular AIX, it'll just be in /, and that will tell you whether or not the makes this be was successful, and will actually show you if there's any files that got dropped or anything. If you need to restore from that NIM resources tar file, then there's a specific procedure you have to follow. And one of the first things you have to do is get the boss inst.data file and fill in the name of the H disk you want to put it to, and then save it back in the NIM resources tar image. So this is showing you how to do that. Don't touch anything else in that image. This is giving you the procedure for actually doing the restore. So once you've changed the boss inst data, you're just going to run install iOS on the command line on the HMC. It's then going to ask you what the managed system is that you want to restore your VIO server from. So in this case, it should be our NIM server. It'll then give you a list of VIO servers, and you have to pick the one that you want to be restoring. And then there's a whole bunch of information that it's going to request from you. And basically then it goes off and it does the restore. Once it's done that restore, and you log in through the virtual terminal, then you don't forget to actually use your VIO SBR to restore any virtual devices to make sure that that's completely up to date. So it's important that you do those VIO SBR backups regularly. The other option you have is to use NIM with your VIO server makes this be image. And in this particular case, you're going to define the makes this be as a NIM object, you'll define the spot, and then you'll do a SMIDI boss inst and do a makes this be restore. Basically the same way that you would normally do one for anything else. And then when you're done, you're going to restore those virtuals using the VIO SBR. And I have the link down the bottom here, which tells you how to do all of that from IBM. So one way that you can save time when you're installing new VIO servers is to build the first one, but stop before you add the network and fiber adapters, and then basically do an alt disk clone to one of the other disks, and then shut the VIO servers down, take away that extra disk, put it in the other VIO server, boot it, and then there's a little bit of cleanup work that you have to do. Personally, I find it much easier just to install 2 fresh VIO servers from NIM and then do the customizations afterwards. But this is one way, if you've got an issue with the disks or anything, you can actually do this kind of cloning. But the tidy up is kind of messy. If you do not do the cleanup, you will get some very strange RMC issues. So the kind of thing that I saw was I boot one VIO and it would say that RMC was active. I then boot the second one. The first one, RMC would go inactive, and the second one would go active. And that's because the node ID was identical between the two. So in order to do the cleanup, if I've cloned from VIO1 to VIO2, I go through these steps where I basically stop RSCT, I clean up the node ID, and then I create a new node ID and basically bring RSCT back up. And then on the originating VIO, I get rid of all of the devices that show as defined, which were the devices that I had in there so that I could do the clone, but now belong to VIO2. So, and then once everything's cleaned up, I bring everything up. I haven't done a lot with Ansible and Linux from NIM, but there's a very good article on IBM Developer that talks about how to run Ansible playbooks from NIM. So you can actually use NIM to trigger these playbooks on NIM clients. It does require that you install Ansible on all of the NIM clients so that you can run the playbooks locally. And all of the RPMs can be found in the AIX toolbox. And of course, whenever you're installing anything from the toolbox today, you should be using DNF to do the installs. We don't do RPM or Yum anymore. And if you go to the IBM AIX toolbox site, you'll find the latest copy of DNF, and you can then use that to actually get everything installed. Also make sure that you install the IBM.Power AIX collection from Ansible Galaxy. And then I've got a link here to an IBM support article on how to install these RPMs using the NIM master. And a really interesting article that I found on Bellissima on actually installing and rescuing Red Hat Linux on Power using NIM. So if you're interested in doing things with Ansible and Linux and trying to control it from your NIM LPAR, it's certainly possible to do so. Now, if you decide that you are decommissioning your NIM server, maybe you've built a new one or whatever, you can't do much with any of the NIM file sets until you do the nim-o unconfig master. That will unconfigure the NIM server as a master, and then you could do the uninstaller boss.sysmanagement.nim master. But you do have to do it in that specific order. I talked a little about this earlier, but you should never export your NIM file system using NFS. NIM will do that whenever it needs to do it, and if you start doing NIM exports, then you're going to have problems later on trying to use NIM. By default, NIM creates an entry in /etc exports, which grants both client, mount, and root access for root users. There is an issue that you may have many clients and need to exceed the 32767 character limit in the exports file. The way to get around that is to use this nim-o change restrict NFS exports equals no, and I've got a link here that talks to you about how to take care of that. And then basically that means that NIM will only grant root access to target hosts. You do still have to obey the NFS limitations of 256 host names, so sometimes you may have to change your export to just be for the ones that you absolutely need to have for that point of time. Or you have multiple NIM servers and you split everything up. I like to see the progress messages as things are going. However, if you don't want to see them, you maybe want to make this completely invisible, then you can set the show progress equals no, and it won't show you all the messages. It'll just sit there until it's done and then finally end. Since NIM is a pretty integral part of what you're doing, in my case it's not just used for doing all my NIM services, I actually have all my backups and software there, and I export those so that I have one location that I keep everything. So sometimes you're going to want to have an alternate NIM master just in case things go wrong. So the way that you do that is you install your boss sysmanagement NIM master file set, and then you, instead of doing your regular SMIDI nim init, you're going to do a SMIDI nim init alt master. And that way, it will take care of doing all of the syncing and everything. And you get it set up, you tell it to replicate, and it will actually replicate the master's resources to the alternate. And if you want, you can add a reset clients yes, and that will rebuild the NIM clients list in etc nim info to be aware of the alternate master. So there's a number of steps that you can go through, and you can basically set it up so that that alternate, you can have it take over from the master at any point. And of course you can always do a nim-o remove of that alternate master. So it's definitely worth looking into, if you have the resources, having an alternate master. If it's like mine, a completely critical part of your setup, because I do all my backups, specifically makes SB backups, and all my software is stored there. By the way, something I haven't really gone into is you should actually regularly back up not just your NIM master makes SB, but also your /nim directory, your /backups directory, etc. Because if you lose those, you're going to have to completely rebuild them. NIM is pretty rock solid, but occasionally you'll run up against some problems. And the kind of problems that you can run up against, I have to say, are typically networking related. So the steps that a NIM install goes through is there will be a boot P, which makes the initial communication, talks to the client. Once that boot P is done, TFTP is used to transfer the boot image, and one of the things you may see is a U0608 hang, and that is typically a boot P or TFTP problem. So what are the things that you can check? So on your NIM server, go into etc.inetd.conf and make sure that boot P is allowed. It's not commented out. You want to make sure TFTP is also not commented out. And then have a look at /etc/bootp tab. If you've configured an LPAR to be installed, the very bottom entry in bootp tab should be for that LPAR. Check all the IP addresses, the gateways, that kind of thing. When all else fails and you've still got a bootp problem, you can actually run bootpd in debug mode. So you would comment it out in etc.inetd.conf, stop all the processes, and then start it from the command line with the user sbin bootpd-s-d-d-d. It will show you the output on the screen, but at least you'll be able to see what's going on when the boot's occurring. Now, if it's a TFTP issue, you want to have a look in /etc/tftp boot. Make sure that it's not at 100%, and then have a look and make sure that there are .info files there for the machine. Also make sure that /etc/tftpaccess.control actually allows TFTP boot, and make sure that the TFTP daemon is running. And again, you can actually run TFTPD in debug mode as well. So you can change it in etc.inetd.conf, adding a -v, and then you'll need to check whatever syslog is set to at the info level in your etc/syslog.conf. And then the big thing that usually gets people is that they're going through a firewall, and TFTP and bootp are not allowed through the firewall. So those are all things that you need to check in order to have a functioning NIM environment. This is a number of links that I find particularly useful for NIM. This year I had an article published on Adventures with NIMADM, so you may find that useful. There's also the Easy NIM Red Book, which hasn't been updated since 2007, but you may find it helpful because it actually has some really interesting tips in it. And a couple of other articles, and then a IBM link on how to back up your NIM database. And these are the links just to the HMC scanner and to the actual command instructions for the various alt-disk, alt-root-vg, etc. commands. Finally, these links are to some of the articles that I've written where you can find some replays. I highly recommend that you join the IBM US Virtual Users Group and go to a lot of their sessions. They have some really, really useful stuff. So I wanted you to have these. Finally, I want to thank you for taking the time to listen to this. You'll find the handout for this at the link listed below, and I hope you found this useful.